Welcome to Blockchain 101, where we unravel the basics of one of the most transformative technologies of our time. Blockchain is often mentioned alongside cryptocurrencies, but its applications go far beyond digital coins. In this video, we'll break down what blockchain is, why it matters, and how it's changing the way we think about trust and transactions. Whether you're a complete beginner or just looking to refresh your knowledge, you're in the right place. Let's start by understanding the core concept of blockchain and why it's considered so revolutionary in today's digital world. Its core, blockchain is a type of digital ledger. Imagine a record book that's not stored in one single place but is instead duplicated across thousands of computers worldwide. Each entry in this ledger is called a block, and these blocks are linked together in a chain, hence the name blockchain. This structure makes it incredibly difficult to alter past records, ensuring that the data remains secure and trustworthy. The decentralized nature of blockchain is what sets it apart from traditional databases, and it's the foundation for its security and transparency. One of the most important features of blockchain is decentralization. Unlike traditional systems where a single authority controls the data, blockchain distributes control across a network of computers, often called nodes. Each node has a copy of the entire blockchain, and they work together to verify and record new transactions. This means there's no single point of failure, making the system more resilient to attacks or errors. Decentralization also fosters greater transparency, as anyone can view the blockchain's history. Blocks are the building units of a blockchain. Each block contains a list of transactions, a timestamp, and a unique code called a hash. When a new block is created, it references the hash of the previous block, forming a secure chain. This linking process ensures that if someone tries to alter a block, it would break the chain, making tampering easily detectable. The structure of blocks and their interconnection is what gives blockchain its security and reliability. Hash function is a mathematical process that takes input data and produces a fixed-size string of characters which appears random. In blockchain, each block's hash is unique and depends on its contents. If any information in the block changes, the hash changes too. This property makes it nearly impossible to alter data without being detected, as every subsequent block would also need to be changed. Hash functions are a key part of blockchain's security. Mutability means that once data is recorded on the blockchain, it cannot be changed or deleted. This is achieved through the combination of cryptographic hashes and the linking of blocks. Immutability is crucial for building trust, as it guarantees that records are permanent and tamper-proof. This feature is especially valuable in industries where data integrity is essential, such as finance, healthcare, and supply chain management. Blockchain's transparency comes from its public ledger. Anyone can view the entire history of transactions, making it easy to verify information. This openness builds trust among users, as there's no hidden manipulation or secret changes. Transparency is one of the reasons blockchain is being adopted in areas like voting systems, charity donations, and public records, where trust is paramount. Add new blocks to the blockchain, the network must agree on the validity of transactions. This agreement process is called consensus. There are several types of consensus mechanisms, such as proof of work and proof of stake. These methods ensure that only legitimate transactions are recorded, preventing fraud and double spending. Consensus mechanisms are the backbone of blockchain's security and reliability. Proof of work is a consensus mechanism used by many blockchains, including Bitcoin. In this system, computers compete to solve complex mathematical puzzles. The first to solve the puzzle gets to add the next block to the chain and is rewarded. This process requires significant computing power, making it expensive to attack the network. Proof of work is effective but can be energy-intensive, leading to discussions about more sustainable alternatives. Proof of stake is another consensus mechanism that's gaining popularity. Instead of solving puzzles, validators are chosen to add new blocks based on the amount of cryptocurrency they hold and are willing to stake as collateral. This method uses far less energy than proof of work and still maintains security and fairness. Proof of stake is being adopted by newer blockchains aiming for sustainability. Smart contracts are self-executing agreements with the terms directly written into code. They automatically carry out actions when certain conditions are met, removing the need for intermediaries. Smart contracts are used for a variety of purposes, from automating payments to managing supply chains. Their reliability and transparency are transforming industries by making transactions faster and more secure. Blockchains can be public, like Bitcoin and Ethereum, or private, used within organizations. Public blockchains are open to anyone and are maintained by a global network. Private blockchains restrict access to a specific group, offering more control and privacy. Each type has its advantages depending on the use case. Understanding the difference helps organizations choose the right blockchain for their needs. Permissioned blockchains are a type of private blockchain where only approved participants can join the network. These blockchains are often used by businesses and governments to maintain control over who can access and modify data. Permissioned blockchains combine the benefits of blockchain technology with the ability to enforce rules and regulations within a trusted group. Cryptocurrencies are digital assets that use blockchain technology to secure transactions and control the creation of new units. Bitcoin was the first and remains the most well-known, but there are thousands of others, each with unique features. Cryptocurrencies enable peer-to-peer transactions without the need for banks or intermediaries, making them a powerful tool for financial inclusion and innovation. When you send cryptocurrency, your transaction is broadcast to the blockchain network. Nodes verify the transaction details, ensuring you have enough balance and that you're not double spending. Once verified, the transaction is grouped with others into a block and added to the blockchain. This process is fast, secure, and transparent, making digital transactions more efficient than ever before. Mining is the process of adding new blocks to the blockchain. In proof-of-work systems, miners use powerful computers to solve complex puzzles. The first to solve the puzzle gets to add the block and receives a reward, usually in cryptocurrency. Mining secures the network and ensures that only valid transactions are recorded. However, it can be energy-intensive, leading to debates about sustainability. Nodes are computers that participate in the blockchain network. Each node keeps a copy of the entire blockchain and helps validate new transactions. Some nodes, called full nodes, store the complete history, while others, called light nodes, store only parts. Nodes work together to maintain the network's integrity and security, making blockchain a truly decentralized system. Blockchain technology isn't just for cryptocurrencies. It's being used in supply chain management, healthcare, voting systems, digital identity, and more. By providing secure, transparent, and tamper-proof records, blockchain is solving real-world problems and creating new opportunities for innovation across industries. Supply chains, blockchain can track products from origin to destination. Each step is recorded on the blockchain, creating an unchangeable history. This transparency helps prevent fraud, ensures product quality, and builds trust between businesses and consumers. Companies are increasingly adopting blockchain to improve efficiency and accountability in their supply chains. Blockchain can revolutionize healthcare by securely storing patient records. Patients and providers can access accurate, up-to-date information while privacy is protected through encryption. This reduces errors, streamlines care, and gives patients more control over their data. Healthcare organizations are exploring blockchain to improve outcomes and efficiency. Blockchain-based voting systems offer secure, transparent, and tamper-proof elections. Each vote is recorded as a transaction, making it easy to verify results and prevent fraud. By increasing transparency and trust, blockchain can help strengthen democracy and ensure fair elections. Blockchain can provide secure digital identities, giving people control over their personal information. Instead of relying on centralized databases, individuals can manage their identity on the blockchain, reducing the risk of identity theft and fraud. Digital identity solutions are especially valuable for people without access to traditional identification systems. NFTs, or non-fungible tokens, are unique digital assets stored on the blockchain. They can represent art, music, collectibles, and more. NFTs prove ownership and authenticity, opening new possibilities for creators and collectors. The rise of NFTs is just one example of how blockchain is changing the digital landscape. FI stands for Decentralized Finance, a movement using blockchain to recreate financial services without banks. With DeFi, users can lend, borrow, trade, and earn interest directly from their digital wallets. DeFi platforms are open, transparent, and accessible to anyone with an internet connection, making finance more inclusive and innovative. Blockchain is streamlining real estate transactions by providing transparent records of ownership and transfers. Smart contracts can automate payments and title transfers, reducing paperwork and fraud. Buyers and sellers benefit from faster, more secure, and more efficient property transactions. The Internet of Things, IoT, connects devices to the internet, and blockchain can secure their data and interactions. By recording device activity on the blockchain, we can ensure data integrity and prevent tampering. This combination is especially useful in industries like logistics, manufacturing, and smart homes. Despite its benefits, blockchain faces several challenges. Scalability is a major issue as networks can become slow and expensive as they grow. Energy consumption, especially in proof-of-work systems, is another concern. Regulatory uncertainty and the need for better user interfaces also limit adoption. Overcoming these challenges is key to blockchain's future success. To address scalability, developers are working on solutions like sharding and Layer 2 protocols. Sharding splits the blockchain into smaller pieces, allowing more transactions to be processed in parallel. Layer 2 solutions such as the Lightning Network handle transactions off the main chain, reducing congestion and costs. These innovations are helping blockchain scale for global use. Energy consumption is a hot topic in blockchain discussions. Proof of stake and other new consensus mechanisms are designed to use less energy than proof of work. Developers are also exploring renewable energy sources and more efficient hardware. As sustainability becomes a priority, the blockchain industry is evolving to reduce its environmental impact. Regulation is a complex issue for blockchain. Governments are working to balance innovation with consumer protection and financial stability. Some countries embrace blockchain while others impose strict rules. Clear regulations can help build trust and encourage responsible adoption, but too much restriction may stifle innovation. For blockchain to reach mainstream adoption, user experience must improve. Many blockchain applications are still complex and difficult for non-technical users. Developers are focusing on creating intuitive interfaces, better wallets, and seamless onboarding processes. Making blockchain easy to use is essential for its widespread success. Interoperability refers to the ability of different blockchains to communicate and share data. Currently, most blockchains operate in isolation, limiting their usefulness. Projects like Polkadot and Cosmos are working to connect blockchains, enabling seamless data and asset transfers. Interoperability will unlock new possibilities and drive the next wave of blockchain innovation. While blockchain is transparent, privacy is still important. Techniques like zero-knowledge proofs and private transactions allow users to protect sensitive information while still benefiting from blockchain's security. Balancing transparency and privacy is a key challenge for developers and users alike. Security is at the heart of blockchain technology. Cryptography, decentralization, and consensus mechanisms work together to protect data and prevent attacks. However, no system is perfect. Developers must stay vigilant against new threats such as 51% attacks and smart contract bugs to keep blockchain networks safe. 51% attack occurs when a group controls more than half of a blockchain's computing power. This allows them to manipulate the network, double-spend coins, or block transactions. While rare and difficult to execute, 51% attacks highlight the importance of decentralization and network security in blockchain systems. Smart contracts are powerful but not immune to errors. Bugs in smart contract code can lead to lost funds or security breaches. Developers use rigorous testing and audits to catch vulnerabilities before deployment. As smart contracts become more common, ensuring their safety is a top priority. A fork occurs when a blockchain splits into two separate chains. Forks can be planned, such as upgrades, or unplanned due to disagreements among developers. Hard forks create entirely new blockchains, while soft forks make minor changes. Forks are a way for communities to innovate and adapt to new needs. Governance refers to how decisions are made in blockchain networks. Some blockchains use on-chain voting, while others rely on off-chain discussions. Good governance ensures that the network evolves in a way that benefits all participants. As blockchain grows, governance models are becoming more sophisticated and democratic. Blockchain is still a young technology, but its potential is enormous. From transforming finance to enabling new forms of digital ownership, blockchain is reshaping industries and creating new opportunities. As the technology matures, we can expect even more innovative applications and widespread adoption. Learning about blockchain can seem overwhelming at first, but breaking it down into basic concepts makes it manageable. Start with the fundamentals like blocks, hashes, and consensus, then explore real-world applications. There are many resources available, from online courses to community forums, to help you deepen your understanding. The blockchain community is global and diverse, with developers, entrepreneurs, and enthusiasts working together to build the future. Joining online forums, attending meetups, and participating in open-source projects are great ways to get involved. Collaboration and knowledge sharing are at the heart of blockchain's growth. Blockchain is a fast-moving field with new developments happening every day. Staying informed is key to understanding trends and opportunities. Follow reputable news sources, subscribe to newsletters, and connect with experts to keep your knowledge up to date. With great power comes great responsibility. Blockchain can be used for good or bad depending on how it's implemented. Developers and users must consider the ethical implications of their actions, from privacy concerns to environmental impact. Responsible innovation will ensure blockchain benefits everyone. Let's recap what we've learned. Blockchain is a decentralized, secure, and transparent digital ledger with applications far beyond cryptocurrency. Its core features, immutability, consensus, and smart contracts, are transforming industries. While challenges remain, ongoing innovation is paving the way for a more trustworthy and efficient digital future. As we look to the future, blockchain's influence will only grow. From finance to healthcare, supply chains to digital art, the possibilities are endless. By understanding the basics, you're now equipped to explore this exciting technology further. Stay curious, keep learning, and watch as blockchain continues to shape our world.